What's true is determined by what we perceive and not what there is. This world only operates on two levels: the macroscopic world, consisting of the huge stars, galaxies, and the whole of the cosmos, and the other, microscopic world, consisting of the cells, electrons, and the quarks. What defines me is the lens with which I look at things, which is determined by the experiences I have had and the values I hold. To understand this, one would have to look at what I am at the microscopic level. The answer lies in the faith that I hold. I start my day by tying my turban. It is this practice which made me realize that I have been applying engineering design principles throughout my life unknowingly. It's very important to have a good base before starting anything, which is why in my high school I took, in poet Robert Frost's words, the road not taken. I chose both biology and math because I realized the overlap and potential of both the tools. To succeed, one needs to go through continuous iterations, and in machine learning terms, training over multiple epochs is required to achieve the best result. A strong design is incomplete without creativity, and the only law which is applicable everywhere is art. Taking bold decisions and having the courage to take up challenges is what adds the X factor. I took inspiration from people's humanitarian work and saw how science and technology could be harnessed to help address global problems such as world hunger. My vision is to have a meaningful macroscopic impact by solving multiple micro problems.
Is the Gurudwara Bangla Sahib temple in New Delhi, India. Open 24 hours a day, 365 days a year, the temple's kitchen or langar feeds 35,000 to 40,000 people every day for free. And on religious holidays, that number can swell to well over 100,000 people. To keep up with demand, the kitchen uses specialized machines that can do everything from chopping vegetables and stirring stews to steaming the perfect dal.
To broaden my perspective and challenge myself, I chose to study engineering science at the University of Toronto. Driven to keep learning during the break after high school graduation, I enrolled in IIT Madras Bachelor of Science in Data Science and Applications. Soon, I became deeply interested in the global climate crisis. In my first summer, I explored the carbon credits market, co founded a startup under the university hatchery, and identified gaps in carbon credit verification. The next summer, I moved into a more technical space, working in the physics department with infrared spectroscopy, studying the impact of Canadian wildfires on Toronto's pollution levels. This is me and my lab mates filling up liquid nitrogen for the spectrometer.
You can see the liquid, the ride on a cushion of gas underneath it.
Following this is when I got interested in machine learning. Artificial intelligence is the closest thing we might have to human intelligence, and I find it best to use deep learning as an analogy to my own thinking. I will treat human intelligence as the outer circle of the diagram on the screen.
Processing, meaning it will automatically learn the right representations from the raw input. Automatically is the keyword. Automatically learn representations, which means that you can give it structured data, you can give it pictures, you can give it text, you can give it anything you want, it'll just learn it. Okay? It can automatically extract these representations, and since it's being automatically extracted, you can imagine sort of a pipeline where the raw data comes in, you have a bunch of stuff in the middle that's learning these representations automatically without your help, and then boom, you just attach a little linear regression or logistic regression at the end, problem solved. That in a nutshell is deep learning. Input, a whole bunch of representations being learned, and then piped into a linear or logistic regression model. Okay? So the amazing thing is this simple idea is just incredibly powerful, right? That idea has led to ChatGPT, has led to AlphaGo, AlphaFold, and so on and so forth. And I kid you not, I've been doing deep learning for about 10 years now, and every time I look at it, I literally get goosebumps every so often. That something so simple could be so powerful, right? It's really like boggles the mind. I'm just so lucky to be alive and working during this period.
Just as convolutional neural networks rely on multiple filters to interpret patterns, navigating the world's complex challenges demands diverse perspectives, like scientific, biological, social, anthropological, ethical, and philosophical.
And if we zoom in, each one of those values is 1/9. And what I'm doing at each iteration is multiplying each of those values by the corresponding pixel that it sits on top of. And of course, in computer science, we think of colors as little vectors of 3 values, representing the red, green, and blue components. When I multiply all these little values by 1/9 and I add them together, it gives us an average along each color channel, and the corresponding pixel for the image on the right is defined to be that sum. The overall effect, as we do this for every single pixel on the image, is that each one kind of bleeds into all of its neighbors, which gives us a blurrier version than the original. In the lingo, we'd say that the image on the right is a convolution of our original image with a little grid of values. Or more technically, maybe I should say that it's the convolution with a 180-degree rotated version of that little grid of values. Not that it matters when the grid is symmetric, but it's just worth keeping in mind that the definition of a convolution, as inherited from the pure math context, should always invite you to think about flipping around that second array.
Our consciousness is like a reinforcement learning system, constantly optimizing based on rewards and losses. But we must ensure that the reward functions we choose aren't driven solely by immediate economic gain. They must also be guided by equity, ethics, and the greater good.
So the RL problem. So one of the most fundamental quantities in reinforcement learning, we're just going to talk about in a bit more detail now, and this is the idea of rewards. So a reward, what is it? Well, it's just a number. It's a scalar feedback signal, this random variable RT. So every time step t, we're going to define this feedback signal RT, saying basically how well is the agent doing at that time step. And the job of the agent is basically to get as many, to sum up these RTs and get as much reward as possible in total. That's what the agent's goal is. Okay, so that was 2 definitions of state, agent state and environment state. Now here's a more mathematical definition of state, which we call the information state, or sometimes called the Markov state. And the Markov state, or the information state, basically is an information theoretic concept. It tells us when we've built a state representation that contains all useful information from the history. So what we're going to do is we're going to define something. We're going to define a Markov property. So this is the Markov property. It's probably familiar to those of you who've studied anything to do with Markov chains or anything like that. It's the same idea. And the Markov property basically says that the probability of the next state, conditioned on the state you're in, is the same as the probability of the next state if you showed all of the previous states to this system. In other words, you can throw away all of the previous states and just retain your current state, and you would get the same characterization of the future. So let's just try and understand what that really means. So I like to think of it this way, that what this is really saying is that the future, what's going to happen in the future, if you have the Markov property, then the future is independent of the past given the present. In other words, that you only need to store this ST here. If you've got this state representation S and it's Markov, you can throw away the whole rest of the history. You don't need it because that history doesn't give you any more information about what will happen in the future than the state that you have. That's what the Markov property means. It means you can throw away everything that came before, just keep your state, and you're good because you haven't given up anything. That state still characterizes everything about the future, all future observations, actions, rewards. The distribution over those events is the same conditioned on your state as it is conditioned on the whole history. So you can just give up this, work with something much more compact, and everything will be fine. So that's the definition of a Markov state. So we can throw away the history now. And another way to say the same thing is that the state is a sufficient statistic of the future. So this state here fully characterizes the distribution over future actions, observations, and rewards. So once we have this state, we can say everything that there is to say about that distribution. Yeah, question?
I think you said at the beginning, though, that the reward comes at many time steps after the action, the observation.
I am deeply moved by the ideology behind the Markov state, that the future is independent of the past given the present. But it is really important that our current intention or in reinforcement learning terms, information state, also values the past experiences, appropriately considering all the perspectives. Apart from technical knowledge, I also took courses in history and philosophy of AI, engineering ethics, and society, which made me aware of the implications of AI in diverse fields, including image recognition, surveillance, and the potential biases that it can carry.
We laugh, celebrating the successes of our sisters with serena smiles. No label is worthy of our beauty.
Google Photos classifying some black people as gorillas. And my colleague Joy Bolamini and I had a paper talking about basically describing the fact that commercial gender classification systems have very high error rates for particularly women of darker skin tones. Another tool that one might think being applied to social analysis of social networks is word embeddings. So think of word embeddings as a space where words that are deemed to be similar to each other are closer in this space than words that are deemed to be different. So you can use these word embeddings to train analogy detectors. And my colleague Adam Kalai and his collaborators recently showed that these analogies can encode societal biases. So I'll give you an example. So you have an analogy: man is to brother as woman is to sister. Man is to king as woman is to queen. Man is to doctor as woman is to nurse. Why? See? So that's what it gives you, but this is a societal bias. Man is to computer programmer as woman is to, gives us homemaker. So you might ask why, okay, so there are these biases in this thing called word embeddings, why should I care about this? Well, you can imagine an automated tool that's being used to analyze resumes, right? So let's say I'm a recruiter, I'm trying to find someone who's a computer programmer whose skills are close to someone with computer programming skills. So I might see things like Java, Python, C++ in the resume, but I might also see that this person is a quarterback at the University of Vermont. This tells me this person is most likely to be a white male. And I might have a similar resume, exact same qualifications, but this person now is a softball team captain at Spelman College, which is a historically black college for women, and so this person is most likely to be a black female softball captain, right? So now if I have this tool that's telling me that the distance of the black female to computer programming is much higher than the white male, then you're propagating these biases, right? So we are propagating biases in ways that we don't even understand right now. One other tool that I want to talk about that is, once again, heavily used in government and law enforcement is face recognition. So I encourage all of you to read the Perpetual Lineup Report, which talks about the fact that 1 in 2 American adults are in some face recognition database. 1 in 2.
Humanity's greatest breakthroughs happen when nations collaborate beyond borders. Collective science at global scale is not just about discovery, it's about building shared foundations for the future of civilization. At the same time, Europe stands at the forefront of shaping the global AI landscape, not only advancing innovation but courageously defining the ethical and regulatory frameworks that will guide it.
So, the European Union has the largest common market, and they set the rules, and if you want to do profitable business there, you listen to those rules. If you want to challenge the system, you can't just question authority, as we were all told when we were growing up. Today, you have to question the algorithm, and that is a staggering amount of power in the hands of these technology companies.
And I'm advocating for standards, laws, and documentation. So I want to close by saying a bunch of other industries have been here. AI is not the first one. So for example, I come from a hardware background, and I used to design circuits, and in circuits we have something called a datasheet. So every component, from as simple as a resistor to as complicated as a CPU, comes with something called a datasheet that tells you standard recommended operating characteristics, disclaimers, etc. Finally, I'll close by talking about a very important industry, which is the healthcare industry. So some of you might know that clinical trials were not legal in the United States. And there were also a lot of unethical drug experimentation that was being done on marginalized communities. So vulnerable people, people of color, soldiers, prisoners, pregnant women, etc. And even once there was a procedure to have clinical trials, guess what? Once again, there was no law that mandated that in your clinical trial, you needed to have people of different groups to test your drug on different groups before you put it on the market, and that you needed to disaggregate all the results by these groups. And again, it was very, very recently that the United States government mandated that this had to be done for clinical trials. So now you have studies that show that 8 out of the 10 drugs that were pulled out of circulation between 1997 and 2001 disproportionately affected women. It took many years for standards to be put in place in these industries, and we're still suffering from the biases that were propagated in these other industries. So we should learn from these other industries and not do the same exact thing with AI. We should have guardrails in place, and we should make sure that the group of people involved in creating the technology resemble the people who are using the technology.
The only way to find the minimum of the loss function is to keep going. So do your best to lay the framework and let there be change.